Selamat Sejahtera, peace be upon you. Ladies and gentlemen, welcome to Lab Asia 2022 seminar session together with Petroliam Nasional Berhad PETRONAS on crude distillation, unit for process control and optimization by simulated distillation gas chromatography. Before we start our session, there are a few rules that we have to adhere. If you have any question, please wait for the Q&A session or do list them down at the Q&A box. If there's any internet disruption during the session, kindly be patient and try to sign in again. In this session, we have Mr. Muhammad Hisham bin Ibrahim, the Principal Engineer from Petroliam Nasional Berhad PETRONAS. Mr. Hisham has joined PETRONAS since 1997, and recently in 2016, he's been given the responsibility to head the commissioning for PETRONAS Rapid Central Lab and spearhead the Central Lab operation starting 2019 until 2022. In May 2022, he has taken up new role as the Central Lab Technical Consultant and Technical Advisor. Well, with that, without further ado, let's welcome him today.
Okay, a very good afternoon and Assalamualaikum, ladies and gentlemen. Okay, what I'm going to present to you today is on the crude distillations unit for the process control and optimization by simulated distillation using the gas chromatography. So, as expected, this is a case study that we have conducted on the CD process control and optimizations at the refinery. Okay. So next slide. So these presentations have this content, which is introductions on what is the simulated distillation is all about, what are the problems and what are the objectives of the study and the scopes, and what are the methodology that we use, and also what will be the results and the future works that we may undertake in future. Okay. As introductions, what is the simulated distillation, or the short course name is SIMDIS. The SIMDIS itself is a method to determine the boiling range distributions in the petroleum product. As you know that chromatography technique is the popular product among all the refiners, and it is one of the major instruments used in the refinery. And however, for this particular SIMDIS, the focus is on the simulated distillations using ASTM method DA 2887, which have a range of determinations between 55 degrees C to 538 degrees C. What is it about is it gives inside information of the composition, which specifically on the carbon number distributions of the feedstock and the product from the refining process. So this will be an alternative advanced technology replacing the conventional physical distillation. As you know, the conventional physical distillation has been used since the startup of the refinery, since early of last century. Then what we have to do now is to move ahead with new technology that will give us a better information of process design and also process evaluation. But as you know, there are three stages for these correlations. On the first stage, we have the correlation study between the D86 data, which is the physical distillation, and the distributed distillation, which the job is to find the correlation factor, the data collections, and also drawing the baseline. What is on the second stage, which is specifically on the application of the SIMDIS itself to the rundown samples, which will be presented on data to operations, selected stream of recommendations, and monitor the rundown analysis. And on the third stage is on increasing our production yield based on the simulated distillation, which is to identify a scope based out of the PMO streams. All right. Okay. What are the difference between these two? I'm going to give a slight information of these physicals and versus the D86. Okay. The simulated distillation itself is an equivalent to the true boiling point test method, which has 150 plus theoretical plates analysis, while the physical distillation is only one theoretical plate analysis. On the fully automatic injection using a SIMDIS. However, for the physical distillation, as you know, we have to manually prepare the sample volume. Well, there is using the simulated distillation or SIMDIS, there will be no loss and residue. However, using the physical distillation, as you will realize, there will be a loss and residue due to incomplete distillation process. And the data reported using the SIMDIS is in mass percent, while using the physical distillation is in volume percent. Okay, the best thing about this distillation or SIMDIS is independent on carbon number. That means if we have more carbon number, then it can detect up to the minimum. I'll show you later on the next slide on the minimum carbon number that we have. While for the physical distillations, it is truly depending on the condenser temperature and also on heating temperature and also depending on the sample size that we use, right? So next slide, please. What are the problems? What are the problems of using these physical distillations? The problem is the physical distillations, we reported the results in volume percent. So the time taken for the process engineer to do the mass balance of crystallization unit is the time taken, which they need to convert this volume percent into mass percent. Okay, and then also this physical distillation, they have a limitations. When there are process adjustment such as pressure or temperature, it will affect the heating rate of sample, which is set manually for the optimization purposes. Okay, this is what we do manually on every single set of samples. And further to that is the calibrations of physical distillation is based on the volume. So there is no particular standard is referred individually to the correspondent volume percentage. We do receive several complaints stating that the results produced is not matching with the best balance activity. So what we did is the changes of the what is because of the changes of the composition itself. The changes of the composition affect the yield of component, which is at the heating rate, so giving a different temperature indication. So in terms of metal accuracy and precision, the repeatability of physical distillations for T95, that is the product specification. For the middle distillate at 340 degrees C is 3 degrees C, while the SIMDIS has smaller variations at 1.2 degrees C. So you can see that the variations of 1.8 degrees C, there is a huge amount of money that we can extract out from the process. Okay, the difference of 1.8 degrees C translated to product yield at 300 kilobarrel per day processing will give a huge economic variations. Right. So what are the objectives of these presentations is to determine the process stream for feasibility study in developing the correct correlation equations. Okay, what we did is to do the test run of the identified process stream. We identify the test run offset value as a common value for all streams, determine the correlation study between the D86 and the simulated distillation as the first stage of the study, which is to find the correlation factor, the data collections, and drawing the baseline. Right. Next slide, please. Okay. So the scope of the study to highlight is to determine the correlation and regression coefficient that best suited for particular samples, and then to identify the calibration data and the validation data for the activity, identify the correct offset value to be used via the regression coefficient or equivalent technique, as well as the investigation of different sample stream on the common offset value. All right, these are the methodology that we use for this particular study. The first one is on the data collections, which 2/3 of the samples collected is used for calibration, while 1/3 will be used for the validation. So once we do that, we have to plot the regression and analyze the difference between the two methods. So there are two techniques that we use, either linear regression or non-linear regressions. So you can see there. I'm not going to dwell details on the linear and non-linear equations. Okay. Then after that, the segregations, the data is segregated between calibration and validation data. So once we already segregate the data, what we did is to develop the multiple linear regression coefficient using the calibration and the validation data. So what we did is to define the appropriate aggregations. So based on that, we have to plot using the calibration data only and analyze the difference between two methods for both calibration and validation. Okay. So what we have to ensure is those process data should comply to the R value of the physical distillation. What is R value? R value is the reproducibility because we are comparing two results from two different methods. So data that does not comply are removed, which is, you have to remember the physical distillation have their R value of 8.5. Those are out, reproducibility of out of more than 8.4 will be removed. After that, the process data will be reprocessed to gain a new coefficient value. So this then is checked against this. The new data is then checked against the validation data. The standard error prediction of SCP for both calibration and validation data is calculated. If the standard error prediction validation is less than standard error prediction of calibration, the regression is acceptable and coefficient can be used. However, if it's otherwise, which is the standard error predictions for evaluation is more than the calibration, we cannot accept the regression and data is out of the partial least square, plot cluster is to be removed. After that, we have to plot the SQC using this new data and monitor using the new coefficient. So if the data set difference is out of acceptable limits, such as 2 sigma or 3 sigma, we have to check again with the instrument, what is the problem with the instrument, normally because of the problem of the calibrations, and as normally if physical distillation is because of the loss of the samples, like components. On the CB itself, because of the calibration. After we have data set difference of evaluating the acceptable limit, we have to replot again regression until the R squared is more than 85%. Okay, so what we did is control chart is plot to have good agreement between two results and to monitor the model performance. So in this particular case, the advanced process control or APC inferential is used to monitor the equations. So offset value is monitored on the oil consistency, and also the correlations is on the offset is determined and tracked. So SIMDIS versus inferential value is also monitored. All right, so next slide. Okay, these are the examples of parameter used and also the equation that we use. Okay, what we did on the parameter, each of that is being used for the mass balance purposes. For the D86 predicted versus the IBP, there's equations, and also for the item number, if you refer to item number 8, that is the product specification. That are the equations that we use for simulated distillations correlations. Okay, next slide. Okay, these are the results that I can show you on the data average data that we have collected for D86 physical distillation versus the simulated distillation. So that are the offset value that we have determined. As we could see there, the trend below, you can see there the trend below. The blue line is the representing the physical distillations, while the red line is representing the SIMDIS. If you can see there at the lower boiling point, simulated distillation give a much lower value, while at the higher boiling point, simulated distillation give a more value. That indicates the yield. That indicates the yield that we can get if you use a simulated distillation. So the tracking is done in such a way to ensure the consistency of the offset value, and the new specification limit is determined, identified as a new parameter control. Okay, the offset value, if on the first table on the right side, the offset value at the initial boiling point is a negative value, which indicating, as I mentioned just now, the accuracy of SIMDIS to determine lower carbon number, which is as low as C3. And the positive offset value determine the final boiling point, indicating a much higher carbon number that exists in the samples, which will provide the accurate process mass balance for crude charge to product charge. So at the front end, SIMDIS provide a much lower value, hence providing accurate yield of lower carbon number, and then translated to more value for the light product. At the high end, the SIMDIS providing a higher carbon value, which translating more yield of heavy product, which translated to more yield of heavy product for further processing. Okay, on case number 2, also you can see another set of examples of another product of another medium distillate product. A comparison between two technique of physical distillations and the simulated distillations. Okay, as you can see there, is giving a similar trend. Same goes to the case number 3, using a similar trend. All right. Next slide. Okay, what I want to show you here is before any SIMDIS conversion. This is the data of lab using the physical distillation versus the inferential. Bear in mind, the inferential value is based on the control set by the value that we have input into the system from physical distillation. You can see there the sensitivity is not good, it's not so good. There are lots, they are overlapping, the overlapping is not good. The variations of the test result versus the information value is bigger. Okay, that is before the seamless conversion. Okay, this is another example. This you can see there on the first up is the vector. The vector of this comparison is not right. Okay, we can see sensitivity is not good. So after we do the simulated distillation conversion, we can see a 31% reduction in error variability. 30% error of variability converted into a product yield will give you huge, for example, 300,000 barrel, 31% additional. That means you have processed another 90 kilo barrel of crude per day. You have more yield on that. Okay. Same goes to the another examples of this after the seamless conversion and before the seamless conversion there. You can see there a vector. We have a good vector, good agreement of the result after the seamless conversion. The next example. Okay. So based on the examples that we have performed, was found that the different stream that have different offset value due to the composition value for each stream. If you refer to the previous slide, okay, the previous slide, another slide, please. Before that, okay, you see here the offset value. The offset value for 3 different cases will show a different value. Okay, that means each of particular middle distillate product need to determine one by one. That means you cannot have one lump sum offset value that applies to all. That is not right. That is not the right decision to make. We have to do it one by one. So we will be quite hustle for this particular activity, but it is worth that we gain a lot of money out of the optimization process. Okay. Okay. However, because of the nature of the samples and sources of crude that is limited, that prevent a standardized value offset that can be used across for all middle distillate stream. This is the problem that we are facing. Same goes to the physical distillation. You have to do the setting one by one when you first start up the refinery stream. So a comparison with APC, the advanced process control differential value is also being monitored and trending is plotted against the different diesel stream. So the comparative data has been promising and encouraging. Okay, what we have to do next is to continue on the second stage objective with various middle distillate point and to determine the final product diesel blend for offset determinations and monitor the SQC trending. Okay, so with that, I end my presentation, which I hope it can give you an overview on what we did and what could be a promising information that we could gain together using the simulated distillation technique.
All right, thank you, Mr. Hisham. So ladies and gentlemen that are currently watching online, if you have any question, I will remind you to drop the question in the Q&A box and we will do our very best to answer the question. So maybe for a start, Hisham, can you let us know can SIMDIS being used and deployed for the light samples such as naphtha and also LPG?
Okay. To answer the questions on the naphtha and LPG, well, LPG, we didn't do any SIMDIS because LPG is too light. For the naphtha, it's possible because for naphtha, you have to remember there are 3 types of naphtha. First one is light naphtha, the second one is medium naphtha, and the third one is heavy naphtha. Will be difficult for the light naphtha because you will lose the light ends. So the information, you might not get an accurate information of the light ends in the light naphtha, but it is possible to do unless if you can control the percentage of loss of the light component. For medium naphtha and for heavy naphtha, it's possible because we have been trying it out, but we still collecting the data and trying it out to see whether is it feasible to do that. But I can assure you, yes, it is possible to do that.
I see. Okay, that's great, Mr. Hisham. Thank you. Maybe you can also explain to us like the refinery stream distillation column is by volume. So how would SIMDIS being used to control as the SIMDIS use weight percentage?
Okay. As you know, the refinery using the physical distillation result, which is reported in volume percent. So once, if you want to do the process optimizations of the crude distillations column using the SIMDIS, the first thing if you have to determine the right offset value. So from that offset value, you have to change the inferential value in the APC system so that it could reflect to the mass percent value. So from there, then you start control your inferential value using the SIMDIS instead of using the physical distillations in volume percent. It's a direct conversion once you get the right offset value.
I see. All right. Thank you, Mr. Hisham. So, ladies and gentlemen, once again, we would like to remind you all that if you have any question, please list them down at the Q&A box, and we will do our very best to answer all the questions. So, Mr. Hisham, another question. Does the all hydrocarbon stream will have different offset value?
Yes, based on the initial study that we have conducted on middle distillate stream, for the three stream that we have conducted, different hydrocarbon stream from middle distillate or from light distillate or from heavy distillate will have a different offset value. As I mentioned just now, you have to do it one by one for all your stream that we are to use the simulated distillation so that you have an accurate information. So that information is to key in into the inferential calculation so you can control your process better.
I see. Okay. Thank you. So far, we do not have any question coming in from the platform.
Okay.
But if you would like, for all the attendees, if you would like to get in touch or get in contact with Mr. Hisham, kindly drop us an inquiry and we will connect you directly to Mr. Hisham. So before we end the session, Mr. Hisham, we would like to ask, like, do you have anything to add towards this session, or maybe what are the goals? What are like the achievement that currently Petronas are striving for towards this specific department that you are currently leading?
So what we are trying to do is to achieve the world best class laboratory, and we are introducing a much more sophisticated analysis indicating, adapting the new digitalizations era, which we hope that we can further optimize our performance as well as giving the best to our customers.
And we will truly believe that you will, with your lead, you guys will also achieve this target.
Thank you very much.
So with that, ladies and gentlemen, before we end the session today, we would like to say thank you to Mr. Hisham for being a part of us, and to all the attendees that are currently in the platform. Thank you for joining the session today.
Yeah.
If you have not visited our virtual exhibition hall, we hope that you will spend your valuable time to explore our virtual platform and start networking with all the industry key players that are currently participating. So don't forget also to follow us on all our social media platforms for more updates. Once again, if you would like to get in touch with Mr. Hisham, kindly drop us an inquiry and we will connect you directly to Mr. Hisham. So once again, thank you, and I hope you all have a great day ahead.
Thank you.
You.